An isosceles right triangle has a perimeter of 94 plus 94 times square root 2 inches. All right, what is the length in inches of one leg of this triangle? All right, so this is isosceles right triangle, and let's look at an isosceles right triangle that is a similar triangle to this one, a similar triangle where its dimensions are easier to work with. So we have one such triangle here, and this is a right angle, this is a right angle, and isosceles triangle. And when the hypotenuse is 1 unit or 1 inch long, then we know the ratio, one of this leg is going to be 1 over square root 2. Um, and then the length of BC is 1 over square root 2, right? Uh, this coming from, like, you have a special triangle with like 45 degrees. So this is 45 degree and this is 90 degree. So we know the similar triangles will have this dimension. All right, and this when we have this uh, triangle, the perimeter of this triangle we call ABC is the sum of all three. Is the sum of all three. So 1 plus 1 over square root 2 plus 1 over square root 2 is 1 plus 2 divided by square root 2. And 2 divided by square root 2 is square root 2. So the perimeter of one such triangle is 1 plus square root 2. Now, this triangle is a similar triangle to this one because it is isosceles triangle. It has a right angle, and then we know when we have an isosceles triangle, uh, isosceles right triangle, the angle of this is 45 degree, 45 degree, 45 degree, and because of the reason AAA, three pairs of the angles are congruent, so this triangle and this triangle are similar, right? All right, and if we know that they are similar, then that means the ratio of the perimeter will be given by a certain factor, and we're going to find out what that factor is. That the perimeter of the triangle, if we refer to this triangle as EFG, this is how it looks like, triangle EFG divided by the perimeter of triangle ABC, which is the smaller one, the similar triangle where the hypotenuse is 1 unit. All right, so the perimeter of triangle EFG is the sum of, well, it's given to be 94 plus 94 times square root 2, right? They tell us that. 94 plus 94 times 1 plus square root 2. All right, and then the perimeter of ABC. So what is the perimeter of ABC? Is 1 plus square root 2. All right, and then we want to find the ratio of that. So the ratio of that is 94. So what that means is the isosceles right triangle, the one that we're interested in, is this triangle enlarged by a factor of 94. Right? So this triangle will look like something like this. 94, 94 divided by square root 2, 94 divided by square root 2. Right? So it's just this triangle enlarged by 94 times. All right, and they're interested in the length of an inch of one leg. So they're interested in this number here. They're interested in this number here. So what is 94 divided by square root 2? All right, 94 divided by square root 2 is equal to 2 times 47 divided by square root 2. All right, and 2 divided by square root 2 is equal to square root 2. So this expression is 47 times square root 2, and which is B right here. All right, so this question is uh, not too difficult. It requires you, like, are you able to come up with this similar triangle with easier measurement to deal with? And this is a special right triangle, special isosceles right triangle, where uh, this is a right angle and this is 45-degree. So when there's such one triangle, when the hypotenuse is 1 inch or 1 unit long, then we know the other legs will be the length of the other leg will be 1 over square root 2 and 1 over square root 2. All right, and coming up with the similar triangles, we figure out the ratio of 94. We enlarge it 94 times. Then we know the actual measurement of the angle that they're interested in. And one of the leg is this number. And simplifying that using the step that I've shown you, the answer is, in fact, one of the leg is 47 times square root 2. So the answer is B.